Okay, so good morning, everybody. So today we're going to be discussing one of the most useful tools with respect to running a big data ecosystem. So a lot of the major organizations and companies in the world use a tool called Hive, right? And we're going to be discussing Hive today, right? So that will be the beef of our discussion today. Now, this one again, it may be one of the more basic Hadoop tools, especially used for big data, but it is also one of the most enduring. So even up to today, a lot of people still use Hive. Okay, so that's why we're going to be discussing it now. Before anything else, I'd like you all to make sure that you log in first to your VMs. So you download the Hive packages. So you can download the Hive packages from here. Right, so you copy this. Then you download it. So this is an example of a VM. So I'm already logged into my VM, and you get Hive. Right. In my case, it's already downloaded, so I don't need to download it again here. But please feel free to download it first. Oops. Let me stop sharing. Reshare my desktop. So this is my desktop here. So you will notice I already have Hive downloaded, but for you guys, you can download it again, right? Just do wget that link, and that should start the download. In my case, I don't have to download because it's already there, right? So that at least while we're lecturing as part of the class, you could start to check if you have Hive installed already. Okay, now let's go back and let's start our discussion. Okay, so as I mentioned, Hive is one of the most enduring tools in the Hadoop ecosystem, and up to today, it is still the most popular tools. There is a study that says that around 90%, not 95, 90% of Hadoop jobs are still can still be solved or written, especially in major ecosystems and infrastructures using Hive. At least in my clients, Hive is still one of the most common tools used for doing big data processing. Okay, so first off, a quick history of Hive. It was started or created by Facebook to manage their data. As you could imagine, Facebook does have a lot of data. So in the early days, they started with an Oracle database, just like any startup in the early 2000. They were thinking, oh, let's use the biggest database out there. So they used Oracle at the time. At that time, they were dealing with 4 terabytes of compressed new data a day, which is actually a lot of data. So they immediately outgrew their traditional database management system. Remember at the start of the class, we discussed the difference between relational databases and the Hadoop system, right? So they immediately hit the limits of that data. Plus, the thing with relational database management system, you're forced to discard information to fit a schema in the database to store the data, or you couldn't store the data in the database. It's a schema on write type ecosystem. Now, Hadoop allowed you to store the files or store the data without having a schema first. So later on, if you find use for the data, at least it was there. This prevented discarding of data early on, and which is one of the reasons why it is still being used up to today. So it's a schema on read system, right? Of course, the reason why people wanted to use database systems is even though they were programmers, people prefer to use tools like SQL as opposed to writing code in MapReduce. So just last week we discussed last week and the previous week we discussed things like Hadoop streaming, right, and Pig. But if you notice, Hadoop streaming is programming, right? It's not quite writing MapReduce code from scratch, but it's still programming. And if you notice, it's much harder, for example, to write an application or to modify that Hadoop application uh, to support MapReduce as opposed to, say, Pig, for example. So Pig was a lot easier to use than Hadoop streaming. But Pig wasn't written to use SQL-like semantics, right? So that's part of the difference. So people who grew up using SQL, which is a lot of people actually in the industry, have difficulty using other forms of other forms or systems such as Pig and Hadoop streaming. Lastly, even though you are new to Hadoop and new to big data, SQL as a language is designed to make it easy to manipulate data. So even though if you're a newcomer in the space and you don't have the legacy baggage of wanting to do things in SQL, SQL still is a lot more efficient than say doing it in Pig script, for example. That's the reason why an SQL-like interface was required, and that's why Facebook itself and a bunch of developers actually in Facebook went around to writing Hive on top of the Hadoop ecosystem, right? So it was inspired by schema on read from Yahoo, which is basically invented Hadoop, and then implementation of the MapReduce paradigm from Google. Although it was written independently from Hadoop, it actually can use Hadoop as a backend. Okay, questions so far? Yeah, okay. And so what is Hive? So Hive is a data warehousing framework built on top of Hadoop. So if you notice, when you say data warehouse, that's like traditional database management systems, right? But it's written on top of Hadoop. Therefore, it's written to make the interface to Hadoop similar to how you interface a data warehouse, which is usually SQL. Therefore, it provides an SQL abstraction on top of the MapReduce framework, right? But it is still a system on read platform. So unlike a true data warehouse, right? When you write an SQL query, you expect a response right away, and the response will be as fast as possible. In Hadoop, when you write a query in Hive, it will still compile the query, run the query, extract the data. So it's still the typical Hadoop semantic. So it's not as fast. However, through the years, the Hadoop ecosystem has gotten better and better. Now, Hive takes a while to run, but there are enhancements to Hive, such as the Parquet file system and things like, for example, using SparkQL, right, that have made things faster. But Hive being the oldest is still the most popular today, and we will discuss SparkQL later. So data warehousing, again, is ideal for analysis and reporting, which still is today majority of the reasons why we create a big data cluster, because we want to create reports and we want to use it for weird. Anyway, here. There you go. So I'm back. So this is the Hive architecture. Okay. So if you notice, Hive will expose a front end on one side. So the user will be here on the left side. And on the right side, you will, if you notice, this is your Hadoop ecosystem. This is a visualization of a Hadoop implementation. Therefore, you have two parts. Remember, in our discussion about Hadoop, you have the storage part, which is the Hadoop file system layer, which is composed of your name nodes, which you interface from, and the data nodes where the data are. And you have the MapReduce portion. In more modern Hadoop cases, this is the yarn portion, where you have a job tracker and you have task trackers that actually do the work. Now, task trackers can be assigned to do maps or reduce or both, right? So you notice Hadoop runs entirely on top, Hive runs entirely on top of Hadoop, right? You have your execution engine, but in this diagram, it's written to interface with Hadoop, but technically speaking, you can run Hive on any type of backend, right? But there are a number of backends that Hive can run on, but Hadoop became the most popular, and it is actually the most optimized and supported. So you will see really giant Hadoop clusters running specifically just to run Hive. A majority of Hadoop clusters actually, or Hadoop use cases in the Philippines actually use Hive, whether in the public cloud or in the private cloud. So you have your UI here where you run your SQL query, it is run on an interface or a node called the driver, right? So the driver is basically a process that serves the interface to you. The driver will then take your command, will send it to a compiler. The compiler gets the data from a metadata store. Now, the metadata store regularly talks to the execution engine to talk to the Hadoop framework to look at what data is available. The thing about the Hive architecture is, even though Hadoop is a schema on read system, Hive overlays a schema on top of Hadoop to make the queries faster. And that's the reason why there is a metadata score here. Therefore, you can create a schema. So again, in SQL, you have two types of commands, right? The commands that manipulate the schema and the commands that run the query. The commands that manipulate the schema, such as create, delete, are schema affecting commands. Those commands propagate the metadata store. And the metadata store will tell you what the table structures look like so that you can run your queries accordingly. The metadata is thus returned to the compiler. Then the compiler will now have a command to run, sends it back to the driver or the plan, and the driver will send it to the execution engine to actually run. In this particular case, the execution engine can run commands, for example, which are composed of commands that are executable, right? Or DML type or data manipulation language type commands, such as select, insert, type commands that run on the tables themselves, right? So these commands are run by the execution engine and are sent as jobs to the job tracker. Now it's up to the compiler to create the plan in such a way that it can run on the Hadoop ecosystem. So you yourself don't even have to know map produce semantics at all. You simply write an SQL query. And that is the reason why even for new data scientists, learning SQL is a lot easier than learning MapReduce. And as you will see later on, learning Pig was easier nga than running diba, Hadoop streaming. Hive is a lot easier than Pig because it is actually a query language built for manipulating data. Of course, the Hadoop ecosystem does its job. It creates the mappers reducers. It gets the data from the appropriate data nodes via the name node, and the results are returned. And when the job is done, it's sent back to the execution engine, who sends the results back to the driver, and the driver sends it back to the user interface. Of course, the user interface can be a command line interface, which we're going to be using in this class, or it can be a programmatic interface. So you can access, for example, Hive via your traditional JDBC, as if it were a relational database management system. Okay? Question so far on the architecture. Again, as we discuss the Hive in more detail, we will discuss these pieces more as well. The thing you have to watch out for is that the driver or the components in Hive run on a separate process from the components in Hadoop. So these guys are distributed, right? These task trackers run on different nodes. Job tracker runs on a different node. Name node runs on a different node. Data nodes run on many different nodes. And Hive runs on a different node as well. So when they say a program is running on the driver, that means it's running on the node that is giving the instructions. It is not running in the Hadoop platform itself. So you have to compile that into a job plan before it's sent to the execution engine, and that's when it runs on the Hadoop nodes. Okay, so therefore, Hive translates that. Hive itself doesn't do any execution. It's Hadoop that does the heavy lifting. Okay, and these are just a description of the some of the key components we discussed already. Driver is the one that faces you. Execution engine is the one that runs. Compile generates your execution plan. The meta store stores your schema. So Hive makes Hadoop schema on write, right? So you're creating a schema on top that makes the queries more predictable to run and makes it easier to run succeeding queries because you only have to write it once. Unlike, say, a Pig command or a Spark streaming command, you have to be aware of the schema all the time. Here, you can pre-create the schema. Somebody else can do the schema while you just manipulate the schema, which is actually how a data warehouse works. There's a new concept here called a SERDE. It's down here. It's short for serializer, deserializer. These are Java objects that can operate on Hive rows, right? So they can operate on Hive rows, deserialize, or vice versa. It can operate from data you give it and put it into Hive rows, which is serialized. Now, SERDE is useful because you want to be able to allow Hadoop to manipulate different types of files, right? So the thing about the Hadoop ecosystem, remember, is that the files can be stored in different ways. So different storage engines can be used. A Serde allows you to manipulate these different types of schemas and files. It also allows you to create different functions or customized functions so for the Hive ecosystem. So you're not limited by the functions available by Hive when it's installed out of the box. You can actually create functions of your own, right? And we will show we'll show an example of a Serde later. So the Hive data model, again, will compose of three major pieces. If you're familiar with database management systems, this should be familiar to you as well. So for those of you who took an RDBMS class. So the basic unit of storage of data is called a table, right? And this is exactly what a table is in an RDBMS system. It is actually composed of rows, right? Each row is a unique record, and each row is described by many columns, and each column is a different field within a row, and that's why it's called a table, right? So it's divided into rows and columns. Now, each table will have a uniform set of columns, but can have many rows depending on the data you're putting in. There are two types of tables in a Hive in the Hive ecosystem, and this is an important distinction. There is what we call an internal table, which is like your traditional database table, meaning it takes data from the Hadoop ecosystem, say it's a file in the Hadoop ecosystem, and stores it here in its own storage. So it creates its own system and creates a separate table for it. Now, the nice thing about internal table is that it is optimized against the Hive structure, right? Now, there's a second type of table, and we will know the advantages and disadvantages of the type table after discussing the second type. It's called a external table. In Hadoop, you notice in your last exercise, your pig exercise, you were dealing with files that were stored in AWS, right? You didn't have to download those files. You can actually run them on AWS, because if you run EMR itself, you can run Hive on top of EMR directly, and therefore you don't even have to move those files. Now, those files are in CSV format, which is obviously not a database format. But notice Pig was able to process those files because you could specify to Pig that the storage engine used was CSV. Now, the thing about Pig is it did not create a copy of the file when you executed the command. So Pig operates similar to an external table in Hive. The data is still stored on those files. They're never downloaded to your system. Therefore, you don't have to worry about disk space, right? In that case, because it ran on the cloud, it was on the cloud. So it is an external table. However, you created a schema on top so that you can execute over and over again certain commands on top of that schema without having to rerun the schema. So external tables keep the files or keep the data in the original storage formats, may it be a CSV file, a binary file, a database file, or whatnot. And you normally use Serdes, which I explained a while ago, to access data from these different external storage types, right? And that's why there's internal versus external table. Then we have a concept of partitions, which basically is a way for you to coach the Hadoop ecosystem. Okay, Hadoop will create folders inside your HDFS that represent external tables and some metadata, right? Whether the table is internal or external. Now, external tables, it can be all in one folder. But in Hadoop, you can actually break them down into what we call partitions. And in HDFS, these are actually different folders. The thing about partitions is you're teaching or you're giving a hint to the Hadoop compiler to say that, okay, these are the more commonly used ways of partitioning the data. So for example, if you're dealing with transactional data, you are more likely to query data on the nearer time periods rather than the older time periods. So by partitioning it by date and time, right, and you run the query on the latest partition, for example, first, you don't have to run it on the whole cluster, which makes it faster. Or if your organization or a particular query is designed in such a way, that data set is designed in such a way that the most common query will always be by department, meaning you will never do a cross-department query, then partitioning your data by department makes sense, right? So this allows you to partition your data. So instead of having one big folder where all the files are, and Hadoop will have, and HDFS slash Hadoop will have to scan all of those files for every query. You can create partitions to coach it into scanning only parts of that. And the implementation is actually in folders, which we will see later. Now, bucket is a further division of a partition to make it more manageable. Now, most people, or at least for us in this class today, we will not discuss buckets in too much details, because the bucket implementation also um, affects the way your storage or your Hadoop cluster is designed. So if the block size of the Hadoop cluster is larger, you will want larger buckets. But since we're not here to discuss Hadoop infrastructure per se, like what is the proper amount of RAM or memory to run a Hadoop cluster, because tools like AWS, for example, did that for us already. We will skip this particular discussion for now. But just note that it exists, and it is a way to further optimize how you run your queries. Okay? So this is what it looks like, the Hive data model. So the Hive data model allows you to do transactional or relational database query-like transactions on a non-transactional system, or an HDFS. So when you run a transaction, it looks at the Hive meta store, so which is where the metadata is, and you have your table here. An internal table is where the table is stored internally here, or a managed table. But if you run it on a external table, you notice the external table will only contain the metadata, but will point to external files in the HDFS file system. Now, both are stored in the HDFS file system, but one only stores the metadata in the meta store, right, which is external table, and the rest of the data is still in the original files in HDFS. And an internal table, the whole table, or the managed table, is inside the Hadoop Hive meta store. Now, again, there are pros and cons to each. Obviously, the managed table or internal table will be faster, right? Because the design of the table is optimized. However, if the managed table was created using a subset of data in the external HDFS file system, then you duplicate the data. So for example, I have subscriber information data, and my most common query is, for example, airtime and balances history. And I create an internal table for airtime and balances history only, and I filter all the other data out. Obviously, the managed internal table is faster in the query, but it's only a subset. However, I lost data already. The other fields that I filtered out will not be in that data set. But the query will be faster if I run that, because it is a managed table. However, if I want to query the other fields, I can't query it on the managed table. But if I kept the raw data in the HDFS, I can create an external table for that, and I can still run the query. So it's a difference between speed and flexibility, right? And Hive supports both models. This is the storage model of Hive. So you can create a table. In this case, this table is called student details, where it's partitioned by department. So you have CS engineering department, civil engineering, and electrical engineering as three different partitions, and you can create buckets of data. So that's how the Hive model looks like. You have a table that can optionally be broken into partitions, and partitions can be optionally broken into buckets, right? So this is what it looks like inside in terms of partitioning. So this is that example, the AWS reviews, which you're going to be using. So we'll use in our example, but you're also going to be using in your assignment. So the AWS reviews will show you, for example, this is the main root bucket. Then inside, you notice there is a partition, right? The partition name is product category. This partition is called apparel. This partition is called home, and this partition is called digital video download. And the data is actually broken down into files inside. But all the files inside actually refer to just one partition. Okay, now let's take just a quick discussion on Hive data formats. So there are many Hive data formats. Text is only one of them. And text is the one that we're going to be discussing in this class in a little more detail. The reason why text is useful is because you can have things like tab separated or comma separated files that are a very common way of exchanging data. Now, the problem lang with text is it is generally not compressed. And therefore, there are many other types of formats used for storing Hadoop data, right? You can store them raw, of course, in their raw format, whether JSON or CSV or XML. For example, they're all text files, but they're not compressed. You can also, Hive also supports, by the way, accessing compressed text files, or you can change them into more optimized file formats. And the most common is actually called Parquet, right, for Hive. So you can create an internal table using the Parquet format to speed certain queries up for optimization. And here's just a quick description of three of the more common types. A text file, against text. A sequence file is actually a combination of text and binary. They just use binary mechanics to separate the detail, but essentially it is still text. But because it is using binary separation, it is now block-based, so it's easier to cut. The challenge with text files, and the reason for the inefficiency of text files, is it is not easy to break a text file into block because they are not because it's not a block-based format. The file is actually a character-based file. That's why it's harder to break into blocks, because each of the blocks will not have a uniform size. As a sequence file aims to cure the limitations of text file by making the data separatable into blocks or fixed size blocks. Now, RC file is an optimization. This is used for column databases like HBase, which we'll be discussing 2 weeks from now. Okay, they are all split-itable, right? Because text files, again, are character-based, so you can split by character. However, when you compress them, text files cease to be split-itable. So that's one of those challenges, and that's why sequence files were invented. Okay, this is, again, a quick visualization of the difference between row-based and columnar storage. So your Hive data will look like this. You have different columns, right? Each table will have a uniform set of columns, and each row represents a different piece of data. While a columnar storage system will have just a column, and the data will be in that column. And, like, for example, we discussed Cassandra earlier in the class, you will have data inside each, right? So you can have an index key called last name, and inside you will have more pieces of data. So that's a columnar storage format. Now, again, there are pros and cons. In columnar, it's very fast to search something by the column that you're using. But searching or filtering anything inside will be slower. While row, it's equally fast on all, but you have to process a large amount of data. This is what it looks like in terms of compression. So as I mentioned, Parquet is now one of the most common ways of storing internal tables, or even creating new external tables in Hive, right? So again, it makes the data from the original text size about 62% smaller. And of course, it becomes partitionable, which is important. Partitionable after compression. Now, there's also a new format, the ORC format, which is actually introduced after Hive 12, which actually further optimizes the gains of Parquet. Now, the reason for that is more political, is because Parquet was written for a competing platform. So Hive wasn't the only SQL on Hadoop platform. There was a competing platform called Impala that was created, and that's why Parquet was created as a format for Impala. However, Impala, I guess, lost the war to Hive. Hive still maintained its popularity, so they created a format, right, similar to Parquet, but all optimized for. If you're going to create an internal table, most people will create it using the ORC storage engine, right? But for most of us, we will be using text or compressed text. Okay. And of course, you remember this, the difference, right? So again, schema on read, schema on write, and it's batch. So Hadoop being a generally batch type ecosystem where you create the jobs and you run the jobs, is generally not meant for real time. However, in terms of size, it really has no bounds, right? You can create a really large Hadoop cluster. Therefore, when you compare the two, right, Hive allows you to get the benefits of SQL, but still run it on Hadoop. So it uses HiveQL, which is kind of like SQL, right? And I'll show you later. It can't be SQL because you have some Hive semantics that are unique to it. A traditional database is still used for interactive, while Hive can be used for OLAP or batch analytics, which is really use cases of data warehouses. It's still a schema on read system, but it does have a metadata store that makes storage of schema faster. You can deal with petabytes worth of data, which is generally why Hadoop clusters are built, right? When you deal with terabytes or petabytes worth of data, usually Hive is already using gigabytes worth of data. You can go back to your traditional database systems. Again, this is distributed using MapReduced, while databases have their proprietary systems and can run in hundreds of nodes. Okay, so now we're going to be installing Hive in Apache Hadoop. So again, this is the hard way, right? Most of the time, you will not actually need to install Hadoop on your systems because we will be using a platform that was already installed, whether in your workplace or if you're going to use it in the cloud like AWS EMR or those made available by Azure and GCP, right? So again, but this is just one of the ways, because if you can do this, then the other ways are easier. Okay, so questions before we proceed? Okay, right, so let's do this. So let's follow the instructions. The instructions again are fairly straightforward, but just a warning, you have to follow each and every step, right? Most of the consultations I get over the week are because you missed a step, right? You missed setting permissions, missed transferring the file, missed setting the environment variable. So just make sure that the steps are complete. Now, if you missed a step, you can always watch the video again to see what steps you missed. Worst case scenario, I've seen some happen already, is that sometimes the Hadoop ecosystem was irreparably damaged. And since you're running on a single node version, if it's damaged, right? So you can reinstall the whole thing just to recreate a new VM and follow the instructions from top to bottom. Okay, so now let's go to our Hive. So first things first, let's uncompress it. So we uncompress Apache Hive. Oops, they're not seeing that. Let's share my screen again. Let me delete it first. Okay, so I uncompress. It's our first step. Then, so we're going to install Hive, right? So first of all, you have to have Java installed, which we already have installed because we installed Cassandra, right? And check my Java home. Right, so there, so that's my Java home, so that's already set. Right, now if Java home is not set, you can actually set that in bash rc. So here I have both Hadoop home and Java home. So my Hadoop, please take note, my Hadoop is 3.3.1, but they did release a 3.3.2 recently. So if yours is 3.3.2, make sure your Hadoop home is 3.3.2. Okay. So echo Hadoop home to check if that's set, right? Echo Java home. All right. So that's to check if Hadoop home and Java home are set. If they're not set, just make sure this is set, right? Again, this may be different depending on where you installed your Hadoop. This may be different depending on where you installed Java. But if you followed my instructions about using the JRE that came with CentOS 7, this should be the path actually for that. Okay. Next step, okay, Java installed, Hadoop installed, Hive, right? Then I uncompress it, I go inside, then I create a Hive home, right? So Hive home, so like Java home, you can specify a directory for that. Let's copy this. Right, then I specify a Hive home. There. Now, if you notice, if I do a echo Hive home now, it's still not found. So you have to do this to rerun. Or you can relog into the system that's also one way of solving. So now I have Hive home configured. Okay. Then next step is I have to create the bin into my path, right? So I do this. So I specify this also. Now the bin is useful because then you don't have to go to that directory to run something. So I also will put Hadoop home / bin there. Now, why is that useful? So let's look at my path now. So path doesn't have Hadoop and Hive, right? I do a source. And I look at my path now. I have my Hadoop directory and my Hive directory. What's the benefit of that? Now I can run the Hadoop command directly from here, right? So I run the Hadoop file and I can run the Hive. Wait, sorry. I made it. You're not supposed to do that, by the way. So Hive will run the server. So, but at least the bin is already specified, right? So we don't have to build it from source. So this is not what we're gonna do. So now we're going to run it. Okay. So here, we have to run the following HDFS commands to set up Hive. Now we don't have to do the Hadoop home anymore because I added the Hadoop command to the file system. But you notice I just booted up into the machine and I did not, how shall we say, I didn't start Hadoop yet, right? So I can start Hadoop 3.1 sbin, start all. Right. So this is to start all the components of Hadoop in one go. So not just the DFS components, but even the MapReduce components. Now that's important because tools like Pig and Hive actually use the MapReduce or the Yarn components as well, as opposed to say other components of Hadoop, like just running the Hadoop file system commands don't need the MapReduce components. So here I'm running my Hadoop components, right? So this is starting up. And let's just wait for this to complete. Okay, so it takes a while. In the meantime, are there any questions? So again, I'm installing Hive. I uncompressed my downloaded Hive. I set the path, right? The bin path as well. So I specified that into both Hadoop and Hive as well, in addition to setting a Hive home. Right. Again, it's taking a while. So we wait until this completes. Now it takes a while for a bit because in my particular case, I only gave it a small amount of memory. I think I only gave 2 gig of RAM. Well, the recommendation is really 4, right? Now if we get a memory error, we just restart the machine and add more RAM. Okay. So now things are loaded. Right. So I'll look at so there. I forgot the name of the command for seeing Java processes done. Go there. No. Anyway, we don't need to run that command anyway. So here, let's now run these commands here to create the working directories, right? So I will now create a temp directory and a user Hive directory. So Hive must get its own directory. So Hadoop SS NKDI temp. So this creates a temp directory in the Hadoop file system, which you recall we already created actually, so that's okay. Then you create user Hive warehouse. So again, create user Hive first. Right. Then, so I think, so this is now one of those problematic cases. So let's see. So my Hadoop did not run properly. Let's take a look. So let's see if there's a problem. No. Let's create the directory. So name node is the safe mode. So we can look at more details about that. Let's see Hadoop logs. Where's my Hadoop logs? So this one tends to happen. So I hear you go. All right. So let's see what today 12. The data a bit log. So I just see the log. So again, there was a problem running Hadoop. So here, let's look at the error. Data nodes, minimum number of live data nodes. Right. So here in this case, the data nodes failed to run. So let us see why that failed to run. Let's look at the data node logs. So Hadoop data node logs. So here, server data node. So it's report has 3 blocks out to supplemental. So here, there doesn't seem to be an error. These are all info. Let's look at the date and time. That's today. So the data node has not started yet. So it's doing a restoration, right? So I think this is mainly because we did not shut down properly. So let's stop all first. Right. So again, if we didn't stop things properly, it could have corrupted the data node. And that's probably the reason why we need to install in some cases. So let's see that run first. So let's do that again. Okay, let's wait for it to stop. Of course, it will also stop the yarn components. And successfully joined. Let's see. Again. There you go. Okay, let's start the DFS components only. So the storage components first only. So it's a bit faster. And let's look at the logs. Again, let's just wait a bit. Let me log in via another window so that I can see what's happening. Let's see what is happening here. Logs. Let's see the name nodes run. So here's shutting down new node. Why did it shut down? And it says node reported block 3 needs registration version. Yeah, so this one is the problem. So in this case, this is the current logs, right? Let's see the data nodes. right, so let's try starting just one component. Do it one component at a time. So here, this is now one fail. Of course, the fastest way to do this is just to reinstall the thing. But let's try to see if we could figure this out. So this one means that there was a corrupted node. So let's start with that. Let's see. Right, DFS. So let's look at the data nodes. They are not running. Let's try running them again. And I will view the logs. Again, this is the reason why it's not pleasant to monitor Hadoop systems. There you go. Let's see why. Because it's on RAM to the main node. Okay, so this is logging so far, so good. Let's see the secondary main node. Hasn't run yet. So this is running. Seems to be fine now. Let's see. Seems to be fine now as well. Okay. Let's test creating that directory. No. So it caused the error when I tried to create the directory. So the problem is something else. Problem is something else. So again, this is a corrupted name node, not exactly the most pleasant thing to throw troubleshoot. Well, anyway, so since we have no time for this class, let me just stop. So let's stop. Make sure you stop all before you before we delete, and let's redo the install for that. Stop all. Stop here. Yes. So let's do that. So of course, the fastest way is again, just get rid of the directories. In this case, Hadoop. Make sure nothing is running. It's still running. So sorry, I deleted it before but anyway, it's just that complete. Let's make sure everything is okay. There you go. So nothing's running. Of course, you can also do that by rebooting the system para malinis. Okay, let's reinstall Hadoop. That's it. Let's do Hadoop again. Let's go back to the Hadoop instruction. So again, if this normally happens because I wasn't able to shut down properly. So the last time I installed it, hindi ko na shut down ng maayos. Kaya, so let's do that. Where's my Hadoop instructions? Or maybe it's because of that. I also said to one student, baka naubusan ka ng disk space. Ayun pala. Okay. Sorry. So I should not have deleted pala. It was not my Hadoop that was the problem. So look at that. I have no disk space left. So let's just delete some of the, I think I have some Zoom recordings that I have not deleted yet. Of course, let's not delete the one today. Diba? There you go. You have space. How much space do I have? 1 gig. Pwede na. Let's go back. So of course, it was now unnecessary pa to delete the Hadoop. Pero sige, hayaan mo na. But let's do it anyway. So I think there was one of you who had the same problem. Naubusan kayo ng space. So I think I should have checked first kung naubusan ako ng space. Again, the Hadoop configuration. Because I don't want to run out of space. Core pala. Oops, this is wrong. Should be here. Should be core. And installing core. So again, just following the instructions. Password SSH will clearly still work. HDFS node format. Okay. Okay, I am back. So the next step was the format step in case you missed it, right? So this one successfully formats, right? The new Hadoop ecosystem. You can start Hadoop by doing start all now. Okay. All right. So this is to start the Hadoop components. Nodes, data node, secondary name node, then task manager, job tracker, or resource manager actually, since we're using Yarn. Let's wait a bit. Here, of course, you will now see logs created. So this one is just displaying all the logs. By typing that command, you're just displaying all the logs in this window. Let's see it start. So this is running, what am I trying to run here? So this is probably running secondary name node, and just name node pala. This is booting name node. Okay. And nodes logs. Okay, then it's now reloading resource manager. Okay, hear that. So here you'll see the logs of resource manager also come out. Right. Data node, name node. Of course, when the resource manager tried to contact the data node, you also see that connection here. Right. This is the resource name nodes, data node. Start. Okay. So let's, of course, since I mute my system, let me create. So /user. Create my user account again. Then set this, create the test. Right. So let's do the test just to see if things are really running. Okay, and let's do this. It's the same problem. Or did they run out of space already? I ran out of space again. I ran out of space so quickly. Yeah, because this is my guest operating system. My host operating system, I have no more space. Look, I ran out already. It says I still have available. This is one of those problems. Right. So again, so I can't demonstrate it to you now because I'll have to clean up my system. But for you guys, you can watch this video here. I did a recording for that before, right? So this one would be a clean install, right? So Hive in Apache Hadoop would be the relevant video for you guys to finish the installation. Well, this one would be the previous lecture I had last year, right? So I'll try to fix my system first because I have no more space, right? And let's see if we can get this to work also. But definitely, if you follow this, you should be able to get it. Now, in the meantime, since I have no time to clean my system, let's do the EMR example for now, because I think that doesn't require much. So let's do EMR first. Well, here you just finish this installation, just to be sure. Then create the schema. Then you can run the command line tool is called pline. Let's do EMR. So let's start our, where's the link? Learner lab. Right. So when you hit installations like that, it's either you run out of space, or again, worst case scenario, you just recreate the VM because it probably was corrupted, right? So, but we don't have time to do that now. So let's do EMR first. Okay, let's start. What are you? Start lab. So I used $17 out of $100. That's actually quite a lot already. So let's do Hive. Okay, so the Hive example that we're going to be using can be found here. So I have an example. So this is what we were supposed to use a while ago for the Apache Hadoop example, but we encountered some trouble. I'll just show you what it looks like. So this is to download Hive, follow the instructions in installing Hive, but you have to replace the Guava in the Hive directory. Again, this is very specific to Hive. Then you recreate the metastore, right? This one only happens because sometimes it will say a metastore error. That's why you can delete the metastore and you can create the database again, right? Then you download this file, right? In these files, of course, you remember how to do that in AWS S3. Then set the proper path and you can run Hive. Once you run Hive, you can run this command. This is a script, right? So I'll explain what the script means. This one simply allows you to run certain services that are in the H catalog. The reason why we need this is because we're going to be using the JSON serde. Now, JSON serde is important because the tweets assignment you have for this week will require this. Okay. So again, I downloaded the impressions in JSON format. I downloaded here to my logs folder, right? And I run. So this one just sets the library that I'm going to be using, JSON serde. That's why I have that. Now this path you replace with whatever Hive you're using. Okay. Next is drop the table if it exists, because this one is I'm running both the schema creation command, create, and I'm running an SQL command as well. Now you can run this interactively in Beeline. You can run this line first, then run this line next, then run the create table, then MSCK repair table is because what I'm doing here is this is an external table. So for the external table to be realizable or usable, you have to run this command first. Specify the schema. Now the actual file itself, let's have a look at that. My internet connection is unstable. I noticed. So apologies for that. Yun lang yung ano. So first, let us. So am I okay now? So let me copy this so that I have a session. Let me copy the credentials. All right, then let's see if that works. Should. Okay. Let's see what the content of this is. So there are files inside it, quite a number, right? Now to copy it, you can do this. It will start to copy the files. Oops. Sample error has occurred. Okay. Right. Very good. Sige nga. Oops. Oops. CP. Oh, ba't ganyan? This one is exists. Impressions. Nagkakaroon tayo ng senior moment dito. Wait, I think it's because we have to recursive mode. How do you do recursive here? Recursive. Dash recursive. So since it's a recursive directory, do you download anything? No. There. I think that should do it. So recursive mode, right? Now, of course, for the exercise, you can download as many or as little as you want. So I'll just abort it. So I just need to test it works. Right? There are quite a number of files. So you really don't need all. Just grab a few. Let's create a log directory and move them there. Let's see what those files look like. Okay, let's pick one. 12, 20. Here's it. There's nothing inside. Let's pick something with something inside. The oldest one will probably have something inside because it didn't copy all. So let's pick the oldest one. 12, 12. Well, 12, 12, 12, 13. Here's there. Okay, so let's go to that directory. Let's check the contents of those files. Okay, so notice it's a JSON file. All right, so the syntax is JSON. Ano yung JSON prettifier natin? Wait a moment. Let's see. There's a command to JSON pretty print command line. There is a way to do that. That's not should be a easier tool. GQ. GQ. So this allows you to pretty print JSON files. So so at least it's very hard to read. JQ. Let's just hope it's in this ancient version of CentOS. Okay. There you go. Should be a small application. Let's see. Right. So here we can see each JSON entry as surrounded by the curly braces. And this is essentially the content. So you notice the JSON schema has curly brace, then your field name, then the value, field name value. The nice thing about JSON schemas, like XML schemas, is they're self-descriptive. Unlike a CSV format, you don't know what the fields mean. Here, JSON, this means number, this means referrer, this means process ID. Therefore, by looking at this, you can say, I can actually use this as my schema, right? So in this case, I'm defining a schema here. So request time, add ID, impression ID, etc. IP are actually all found here at ID, impression ID. So you notice it doesn't have to be in sequence. So I basically took the fields, I specified a data type, right? In this case, they're all string because they're not supposed to be computable, right? Because it's a log file. I mean, if there were a count or like bytes sent or something like that, then it could be, but this is not. So this one I specified them as all string. Now you have special constructs like this. So timers, this is what that looks like. So it's layered, right? So that's why the schema in Hive is not exactly SQL compatible because there's no such mechanism like this in SQL. So this one allows you to create the structure that has more field, more attributes inside and they have specific values. So this one is basically simply a mapping of this. Okay. Then you would run this. Okay, here I specify the partition, right, by string. In this case, date time, which is already the partition actually here. See, partition is DT. That's why I'm telling it to just pick up the existing partition. It's a JSON Serde, and I picked up the location, right? Now, this is what I would run if I were running in this machine, but I'm not, right? So I'm going to run it in here. Okay. So let's get the version that I created for running it in EMR, right? So in most cases, you're going to run it in EMR or Azure or GCP. So here, let me do that for you. Where is that example? Here. So this is the example for EMR. Now it's roughly the same, right? Except that, of course, it doesn't have the instructions on how to install it on premise. But the location of the jar is specific to the location of the jar in EMR, right? So I already looked at the EMR documentation, and this H catalog jar is found in that location, so you don't have to redo it. Now you have to do a drop table because EMR steps are what we're going to be using. So every step has to execute in a new cluster. So just to make sure that the table does not exist, then let's do this. When we create an external table, same syntax, except for this location. So this location, you notice I didn't download it anymore because we're going to process the data that is already in AWS EMR. So I simply pointed it to the location there. Then I did the select count request time from impressions, right? So simply count request time from impressions is simply counting the number of records in this entire sample repository. Now, everything else is the same except the location, right? So what happens here is this one again runs and puts the output in standard out. And that's why we have to look at it in the logs in standard out. So let's get that running first because it takes a while, as you probably experience in your previous activities. It takes a while to run an EMR example. Let's do that. So here, let's create a new cluster. So let's call this CS 173 Hive example. Okay, and we do stepwise execution. Let's wait a bit till the steps come out. I'm having internet trouble today. There you go. Hive. I specified then the script. Oh, sorry. Before all of this, I have to go to S3 first because I have to upload the script there. Okay, so let me go to S3 first because let's assume we're doing this from scratch, right? I can use this bucket, this test bucket, and add my Hive folder here inside the test bucket. Inside the Hive folder, I will upload that script. Again, remember, use the EMR version. The only difference is where it picks up the file. So in my case, so EMR version. Okay. So because if you don't use the EMR version, it will try to load it from the local Hadoop, which if you install a fresh Hadoop cluster will have nothing inside and it will fail. Okay, so here, impressions, EMR example are there. Let's go back to EMR. Let's create our cluster, CS173 Hive cluster example. Okay. Let's do this. Step. Internet's slow today. So uploaded the file, wait for the steps. There you go. Hive. I configure. So this is a script. I pointed to the script I just uploaded. Right. Input is nothing because I don't have an input, but I have to, as I mentioned a while ago, specify an output. Just put the output there. Right. Although the output will not be used because I basically logged it in standard out, but you have to put an output anyway. And once you're done, if there's a failure, terminate plus. Again, don't forget that because it will make your credits run out quickly. Right. I can use any version. Let's run the large instances so they get provisioned faster. Terminate cluster is fine. You don't need to scale out because this is a very small job. So I could. Okay. All right. So just so now we're running it and we wait a bit. Okay. So are there any questions so far? So this is running it on EMR. It's slightly as I say, slightly easier than, of course, installing it yourself. Okay. So let's wait for that while I sign this. Let's wait for that to run. Wait lang, wait lang. Just a sec. No questions. So while it's running. So this one, again, like the last time, parang how long did it take? 88 minutes, no? So just wait. So this one here. So instead of big steps, you know, this is a Hive step. So it's a Hive program. The log should come out here when they're available. In the meantime, we wait. Wait for provision like that. Okay. So let's just see what else. Okay. So this is Hive on EMR. So I used EMR instead, so which is kind of DIY. But Amazon has something called Managed Hive, which is called Athena. So you can run it and it can create a Hive cluster for you that's a little more permanent than EMR. But for the purposes of class, since we don't need the cluster to be running all the time and we don't need the schemas to be permanent, it's better to use EMR step execution because it's cheaper. And if the goal of the class naman is to learn EMR, that should be so efficient, right? So if you are to, again, this is also the instructions on how to run EMR, but I effectively showed you that already. if you need to run a different query in steps, you have to run the step again. Right? Wait, where's my step? So, impressions, EMR example. So here, if you notice, it created a table and it ran the steps. And you can run as many of these queries as possible. But every time you run the script, it creates the table again, which is not how you're going to do it in real life. Now, in real life, when you create the Hadoop cluster and you provision it, you keep it running, right? You don't terminate, you don't use step-based execution for one. And you create your Hive cluster and you basically run. Then you can run by a beeline, you can log into your cluster and you can run as many of these queries as possible. But sa atin kasi, since we're only running it on demand, that's the reason why we created it as a script like this. So all of this gets executed, the creation of the table, the specification of the external table, pointing it to the location, and actually doing the query. Of course, the query here is pretty mundane, but this is just to demonstrate how you're going to use it. Now, for your activities, you don't have to worry because you have a choice to use Apache Hadoop or EMR. Now, again, I wasn't able to get it to work here, but you can watch this video for instructions on how to get it to work. Right? This one here. Right? This is from scratch. Or you can actually try to use it in EMR, which I am showing you right now. Now, of course, the EMR is the easier way of doing things, but again, where's the fun in that, right? So at least you can start with this, right? The EMR is really just running it and waiting it. And of course, as you already did the previous exercises, medyo boring siya, diba? Kasi sometimes, it runs and it waits and it does not, it doesn't finish right away. And you have to wait until it completes. That's right. So yung if you're testing code, mas madali mag-test sa Apache Hadoop. Yung lang is that there was one of you that had trouble because when you were running Spark streaming, now for Hive and Pig, that is true. Because if it fails in Apache Hadoop in pseudo distributed mode, it will also fail in EMR. So what you see na error in EMR, in Apache Hadoop is reflective of the error in EMR. However, for Hadoop streaming, that's not true. In Hadoop streaming, it may work in pseudo distributed, but it may fail in EMR, or if you run it in real distributed mode. Because Hadoop streaming, you have to create the mappers and reducers yourself, right? So yun lang yung siguro thing that we have to take note of, na when using Hadoop streaming, we have to be cognizant about how we write the code. We really have to break it. So the mapper must do nothing but create the keys and count one. So it has to be key, comma, one lang talaga. While the reducer does nothing but consolidate those or do whatever action you need to create those. So that's the thing that you have to watch out. But that's a very good point, Fides, that parang it's usually faster to install and to test in EMR, particularly yung mga Hive na examples. Kasi you want to run the query. If you make a mistake with the query, if you do it in EMR, you wait 15 minutes again, right, to do the query again. Okay, so this one is now running. Of course, the run should be like blip really fast. So it's actually technically not running yet. The nodes are running. It's probably still installing. Yeah. Although in this case, I ran it on the entire sample, right? So not only the subset of the sample, but the entire sample. So medyo mas malaki yun. Okay. Right. So we shall. This takes a bit. So data is running on the entire sample data set. So which is nice because I didn't have to download the entire sample data set from AWS. I kept it there and I left it running there. Here, see, it's running this Hive script. Supposed to put the output there, although output doesn't really have to be placed there because there's really no output because the output I told it to display in the screen, which I'll show you why later. Okay. Still running. And just a warning pala, ditong mga used $17 out of $100, this is not updated in real time. So just because it says it's still $17 now, it doesn't mean you have $17 left, right? So there's like a batch process that updates that. So warning lang. Okay, so hindi to nag-update in real time. So try to save your AWS money. Okay. Malaki job to. I could just said run it on a subset of the cluster. Diba? So here, see, so I'll have to fix that. I'm running out of space, especially since we're recording this class. Right. So here, this one is what happens when you do the MSCK partition. Right. So it actually adds the partition to the metastore. Let's see if we completed that. Right. So the logs say it added the partition to the metastore. Look at the controller logs. So it's ran the step. Right? This is the details of the step that was running. This is the script that's running. I can run that. It's redirecting output to output and standard error, which is what we're seeing in the log files, right? And it's still running. So it's still actually not complete. So at least we can see the log files here. Right? Hindi pa siya complete. See if there are some errors. Right, so this one, wala naman. In this case, so here is the output of the query. So the first query was the add. The second query was the drop, if exists. And I think the third query is the create. Right, so this one means it should have executed already. Let's see. It should have executed already because it said it counted number rows. So let's look at the standard out. Then here is the answer. Right, so the output, it did not put in standard out because I didn't tell it to put standard out. I actually said, I just displayed it in the driver. So that's why the output comes out here. So for this particular record set, I have a million rows, right? So this is the output. Now, if we look at the EMR directory, so this is done, right? If you look at it, it's already terminating. Should be terminating and should be done soon. So steps executed successfully. If I look at S3 in the output directory, should be nothing but success in the output directory. Look at that. See, so there's nothing because it really did not. I did not write anything in the output directory. I just displayed it in standard out. So that's one of the things you just have to take note of, that if you display things in standard out, they appear in the log file because the driver was the one who ran it as opposed to the application itself. So this one successfully ran. It's the first time I run something that successfully ran the first shot. Right? And the output is here in standard out because my script, diba? Notice I did not tell it to put it somewhere else. That's why it is there. Okay. Questions? So that should be enough to get you through the two exercises. We have no class next Saturday, right? So we will have no class next Saturday, but I will leave you a video that you can watch, and there is another Hive example, and there will be another Hive exercise due. So there's one due next Saturday, and there's one due the following Saturday. Okay? Questions so far? And I think that's it for today. So if there are no more questions, I shall stop recording.